Hi, in this tutorial we are going to learn how to modify a 3D shape by a jit.catch object. In our previous tutorial we saw how to modify the dimensions of a 3D shape. We are changing here something more, well, this is a little bit more detailed. We need to understand that here we are modifying also the dimensions, but in a different way. We are modifying the planes of the shape. And so let's review how to do this in theory in a different outside the patch. First of all, let's remember what is the objective of this patch. So I wanted my audio input signal, specifically the amplitude, modify a 3D shape, and I would like that each plane will be modified separately, X, Y, or Z. So let's build the architecture, the fundamentals of this patch. In one side I need an audio signal, and in the other a 3D shape. In some part of the process I will need to perform an operation in order to probably add both sources and as a result obtain the modified shape by the audio. Yeah. And I will need that this operation be performed in each one of the planes separately. So I will need to perform an operation in a matrix that will have three planes, one for X, one for Y, and the other for Z. So do you remember how to perform multiple operations with the OP jit.OP object? We saw that already for a chart matrix type. We're gonna make a little review about that and later see how to apply that in this example for 3D in a geometry matrix. So before, in lesson number 5, when we saw the patch 12b matrix operations, we saw a matrix called multiple operations. And so here is how it is done. In order to perform operations in single planes, in the separate planes of a matrix, what I need is a jit.op object, and later my operator, when I will specify that, I will write one operator for each one of the planes. So in this case I have a pass for the first plane, which in this case is alpha, and a multiplication operator for red, green, and blue planes. And in my second inlet, I am specifying the operands that in this case are scalars, and I will give here the values to modify the red, the blue, and the green. So in this part of my process here, I will need to perform the same, but in this case I will not be modifying the color planes. Instead of red, green, and blue, I will modify X, Y, and Z. Alright, but the technique is the same. So this technique is going to allow me to modify the shape. In this case, let's say that I have a cube, and for example, when I modify the X with the X operator, I will performing a modification, for example, making this shape, larger in the in the X axis. Or if I perform the operation in the modifying only the Y operator, my shape will get bigger. vertically here in the x axis, and the same for the z axis. So I will grow my shape. And so this is why I want to perform the operations in the plane separately in order to modify them this way. So let's come back to our blueprint, our patch blueprint. This is the structure. And let's see which objects can do the job for each one of these tasks. So in order to grab the audio part, we are going to use the jit.catch object. So in this case, I am using this object because this object allows me to visualize audio in a very detailed way more detailed than PCAM, because here this object can behave as an oscilloscope, and when you want that kind of detail in your visual modifications, it's better to use this object rather than PCAM, which is only going to grab the amplitude. So after grabbing the audio part with jitcatch, we will need in some point to perform these operations, and we know that here we will need a jit.op object, and since this object needs a matrix in its inputs because it's going to perform operations between matrices, right? So I need to give it a matrix in here. So I will transform the input of this jit.catch object into a three-dimensional matrix. So, and this matrix also needs to be a float type, because we are going to be dealing here with 3D shapes, and this is why we'll need this kind of data type. In the other side, before that, also we need this float type, because the data collected by jit.catch is arriving in float 32 type. So this is an important reason. So now in this side of the patch, we get the 3D shape. So the object that is going to give us a 3D shape is jit.gl.grid shape. So, and we will need as well to transform this shape into a matrix, because we'll need later to perform an operation between two matrices. So in order to convert this jit.gl.grid shape in a matrix, we will need in some point of the process here as well a matrix containing also 3 planes, and it will be a matrix of float 32 type. So I'm not giving all the details right now. I am just showing the most important objects of the process first, because we need to understand which is the structure. Yeah, so this is the structural structural objects that are more important in the process. So as I said before, once we have the two matrices, three plane matrices in the same type, which is float, we can perform the operation between these two matrices. And the operation needs to be performed in each one of the planes separately. So I will have here three different scalars, three different operators, each one for each one of the planes. And at the end of the chain, I will need an object that allows me to actually visualize the result of this operation. And this object is jit.gl point mesh. We are going to see this object in much detail when we see the GL part. For now, let's just say that this object is going to allow me to actually visualize a matrix. So this matrix is going to be the result of the operation between the audio and, well, the audio that is already stored in the matrix, and this other matrix that is my shape transformed in a three-plane matrix. And so jit.gl.mesh will allow me to show the modified shape by the audio. Yeah, so, and finally I will need something to render what is in here and in here. And in that process, when I have 3D on GL involved in the process, I need always have to a render part in that process. And for that, I will use a jit.world object, and this object, as I explained before, is going to allow also to visualize. It's a window and is a render object as well. So this is the architecture of the patch, and once it's understood, now I will show the patch and I will ask you to identify each one of the structural parts of this patch, and there's going to be things in between, all right? But just keep in mind this is structure when you look at the patch, and I suggest to do that every time you look at the patch. You try to grab the structure, which are the structural objects, the most important objects that are performing the process, because when you open a patch, there's going to be lots of stuff here in between, yeah, but not everything is so important. Yeah, it's let's understand which the structure is, and later the details and the decoration, like a house, all right? So let's look at the patch. There it is. And can you see where is the part of the patch that is grabbing the audio? Yeah, this part is in here, right? And the next step, in which part of the patch I am transforming this, where I am storing this data in a three-plane matrix. Where is the audio data stored? Let's see, yeah, right below. And later I have other stuff. I will not mention that right now. Let's first keep understanding the structure. In the other side, let's see, I get my 3D shape, which is given to jit point matrix of three planes. Let's see where to find that. Can you see it? Try to do it first. Yeah, it is right here. Yeah, and later, this is the way I am just transforming this jit.gl grid shape data into 3D plane matrix is a jit point unpacked object, which is doing the job. So what is happening in here is, remember that each time that I unpack with jit point unpack, my output is going to be a matrix. So this is, I'm saying here, you will have only one output. This one output is going to have a matrix that is going to have 3 planes. All right, and that's how I am building this matrix from here. And I am giving that for the first input to my jit point op. And in the second inlet, I am just grabbing what I collected from my audio part from jit.catch. So ignore that. This is my audio, and it's coming from here to this operator, to this operation object, which is this one. And this part here, where I am specifying the operator for each one of the planes, is specified like that. So look, I have this jit point op, and the operator, I have 3 operators actually. I have the first one is set to pass, the second as well, and the third to plus. And so this will be my X, my Y, and my Z planes. And in this part of the patch that corresponds to this, I can set the values of my scalars. So I can specify, I can change actually my operator from plus to different operators, and I can activate as well the operators for each one of the planes. Yeah, so what it is important to understand so far is that this matrix in here and this matrix over here contain 3 planes, and these 3 planes here at this point correspond to X, Y, and Z, right? So since this matrix contains 3 planes as well, when I will multiply this matrix or add up that matrices, so I will be adding each one of these planes to the X, Y, and Z planes. So it's important to understand that's the reason this one has 3 planes and this one as well, in order I can perform the operation in each one of the planes. And finally, at the end of the chain of this process, I got the object that is going to allow us to visualize the modified shape, and this is jit point mesh. Okay, and okay, before continue, let's perform some operations here and see, look at the results. So here I am affecting the Z plane by a plus operator. Okay, and if I pass it, anything is going on. Now let's see about the Y operator. Can you see that it is now being modified vertically? And now the X. Yeah, and see what happens when I perform the multiplication in the this is the multiplication operator, right? Only in the Z plane. So when anything is going on in the others, it looks flat. And okay, this is the plus, and well, you will explore that by yourself. And once we have understood the architecture of that, which are the structure of this patch, let's look at the details. So there's not many. So I just get here in between my jit point before giving this information to the jit point op object. I have an optional jit point transpose. Do you remember that operation? We studied that before. This operation is going to allow us just to transpose the matrix. As you can see, this is the original and this is the matrix transposed. Yeah, it's going to transpose the data. And so look at how it looks when I transpose the data. This first, I will just perform right. So I will perform the transposition, and look. This is what happens. And later, I have multiplication here. So this jit point and just the operator is equivalent to a jit point op, and later my operator set to multiplication is like a more simple way to do it. And here I'm going to just scale the data that is getting in here, so I can make the thing more exaggerated if you want. Yeah, I'm just increasing the scale of the values that are affecting the shape. And finally, here I have my jit point slide. So remember that this is going to draw kind of morphing between the values of the different cells of the matrix. So this is in order to make the movements smooth. And well, I think that's it. Well, here I have the dimensions of this shape. I can change the dimensions of the sphere here. For example, if I put just 8, look, this is trying to draw a sphere only with a grid of 8 or 5. Here is not even a sphere, and voila. So my sphere will have less edges if it is bigger. Okay, and if I increase, well, just take in account that if I increase those numbers and your GPU is not really powerful, you can have problems. Your image can look slow when you do that. And in other hand, you got in here. Let me put this down. Yeah. So here you got the dimensions of your matrix. And so when this is going to be changes here, we are going to be reflected into the detail of the modifications, right? Because if you put here like 1, you just have like, it's like if you have just one cell here that is modifying this shape. So look, if you get 2, look, you have like 2 divisions now, and so on. Now it's divided in 3. So each one of these parts corresponds to a value that is stored in a cell. Important to understand that, yeah. So imagine when you get like that, this is each one of these divisions is containing the value of a cell of this matrix. And so voila, I think that's it. Remember that in Mesh you can also visualize your shape in points, for example, which can be interesting. If you point, you just set draw mode attribute, voila, draw mode attributes to points, for example, or lines. You can visualize it now in points, etc. And later, I just modify something else, sorry. Well, and later you can modify the size of these points, etc. Well, this is it. Well, I just forgot to mention that here you get your rendering part, which will be represented in here. Just important to know, this has the name catch, and I am drawing to catch normally. Well, now they're connected. If you want to specify this one more clearly, you write here the attribute grow to and you write catch. Okay, well, we'll see that in detail in the GL part. For that is all. So in the next tutorial we are going to see how to apply this technique that we just saw here in order to modify not a shape but a surface with the NURBS object. And so let's see that on the next tutorial. As an exercise for this patch, you can try to modify the shape here. Try well, not only the sphere but the cube, etc., etc., and see what happens. Also try to modify that to different operators and just see what you like. As well, as you can see, there's many processes happening here between these metrics and later and before the operation. We perform a transposition, but you can try to put to add different processes between these two steps. Other operations, maybe you can perform many things in here. Just try to be creative and see what you can do in here. And later with mesh, just try to modify the attributes of mesh and just look how that is affecting your shape, the shape that you are visualizing. That is already the result. So this is the exercises that I am proposing for this patch. See you in the next tutorial.